Welcome to the final part of this 5-part tutorial series covering how to convert two-dimensional data and map data from ArcGIS and ArcScene into three-dimensional interactive environments. In this part, we will be bringing all the files that we worked on previously and converted into formats that Unity Engine can use into Unity Engine and create a very basic environment using the Gaia asset package. To start with, make sure that you have Unity open. In this case, I opened Unity and I started a new project called Tutorial. And I brought in some standard assets, mostly cameras, characters, and environmental effects, as well as the Gaia asset package. The Gaia asset package can be found on the Asset Store. Simply type in Gaia, and it will be the first thing that comes up. It is by Adam Goodrich. At this stage, we need to bring in our files. To start with, let's bring in some of the GIS, in particular our tutorial LiDAR data, as well as our models. If you remember correctly, in the last stage we converted our anchors WRL file into an OBJ file, bring in both the OBJ and the material, as well as the buildings tutorial OBJ and MTL files. The last thing that we will be bringing in are the two DAE files that we created, which was ID5 and ID8. Now, when you start up Unity, you'll have this blank space. What we need to do is we need to make a terrain. In order to do that, first we have to convert this image of the LiDAR into a format that can be used. To do so, go to Window. After you've downloaded Gaia, it will add this little bracket here and show Gaia Manager. Click Advanced, Utilities, Show Scanner. This imports a scanning object that will scan an image file and create it into a file that we use for our heights, or for our data in our height map. Drag and drop. Now it's going to look a little odd at first, and that's perfectly fine. Obviously, we do not have this kind of a height. Set base level to 1. You can save this wherever. I usually just do ad hoc, tutorial LiDAR, Gaia material, save scan. What this process is doing is making our image into a format that the Gaia program can use in order to create a terrain file. Once that has been done, you can delete that object. If you go to Gaia, Stamps, and Ad Hoc, you will see that our file format has been changed into something that is a stamp for Gaia. Now all we need to do is create terrain, show stamper. What this does is it creates a very basic flat terrain file for us. If you look under Gaia environment, you'll see terrain here with all of the basic information. This part right here, the resolution, we will be changing momentarily. For now, let us work with the stamper. This is how Gaia stamps terrain, i.e. how it creates terrain. What you want to do is go back to where you saved your stamp, click your file, and drag it to here. Currently, this is what it won't be like this, and part of the reason why it looks like this is currently the height is set to 1,000. A unit in Unity is typically considered 1 meter. Set your height. Typically don't modify your height any. Allow it to remain as is. So 5 works. Click Fit to Terrain. Stamp. You can delete the stamper, and now our terrain has been stamped. However, you'll notice it is not accurate in terms of the heights. Now we can modify this a little bit. First off, if you remember correctly, on our image file, or on our file, we wanted it to be very specific in terms of the heights. Now, we may want to actually go back and modify our image a little bit, because I am seeing some parts that look like there was some bleeding for the height information. And I can see it here along the edge where you see these tiny little pixels that came through as being higher than they should be. So let's go back to our image file and make a few adjustments. Takes a little while to load sometimes. Just this the old-fashioned way. Oh, another thing that might help your computer save some processing time, at least for this stage, go to Windows, Lighting, Settings, which will bring something up like this. Uncheck Auto Generate. Alright. If you remember correctly, here's our image, and you can see that there are some pixels that are coming through as being white along the edge. There's a few ways we can fix that. For right now, let's just go ahead and select just our height map. Now it's important, the other important aspect of this is see down here at the bottom of the screen where the pixel rate is changing based off of a few value, or how I change this. You want to memorize what the highest one is. And what we're going to do is we're going to cut this out, create a new file that has dimensions of 3850 by 3850. Don't save. Resize. Pixels. Don't maintain. 3850 by 3850. Okay. And paste. What this did is it converted and made it into an actual square. Take your fill tool, fill the bottom, and then zoom in, and with a brush at the minimum size, you can go along and fill in those pixels that are causing some issues. Now you can do this by hand or in the program, and I would just get these few spots real quick. As you can see, I'm kind of modifying the edge here. It's not going to be a huge factor. It's also why we made our anchor points, which connect to this corner, bigger than necessary. Now you can go along the edge and do this for all the points, or you can modify it in the program. Either way, it's not going to have too much of an impact on your data. Hit save, JPEG. Let's go ahead and overwrite that file. Exit out. Let's go ahead and bring that new one that we just created in. Now it may need to overwrite it. Just adds a number, which is fine. Go ahead and delete that terrain file. Utilities, scanner, same thing that we did before. I'll save this one as mod. Save it in ad hoc. Base level 0. Save. Remove that. Create your terrain. There's our flat terrain again, and our stamper. Go to ad hoc, drag and drop your modified file. Everything should be good. Get to terrain and stamp. Remove the stamper. Alright, now the reason why we did the black on the bottom is you can see it down here. We now have a completely flat at the lowest point, which means when we drop the terrain, you won't see any of this. If this was still white, it would all be at the highest value, which means it would be at the highest value all the way around and be impossible to see. Now, let's modify it so we actually get a decent looking terrain that is more accurate to the height and the size. As I pointed out in the previously, a unit in Unity is often considered a meter. Currently, if we go into Tools or into the Gaia Terrain Session Manager, let's not worry about sea level. Terrain Helper. You'll see that there's a lot of different things we can do. But before we want to do any of this, we want to adjust our terrain height. Now, back in part 2, I asked you to get measurements specifically for your east to west and your north to south values. This is where those values come back into play. Previously, the width, in this case the width is the longest point, was 4,035 meters. So change your resolution terrain width to 4035. And do the same thing for your length, 35. Because if you remember correctly, in the step that we just did when we modified this terrain a little bit in Paint, we gave the file the same values. We made it a square. So it was 3,850 pixels wide and 3,850 pixels long, which includes this bar down here. And now it is all the same. The height is still off, however. What you want to adjust is this value. In the GIS, we subtracted the height and the highest points and the lowest points. Let me go back and get those values real fast, and then we will modify the height here to accurately show the appropriate height for this terrain file. You also lose a little bit of detail by doing this methodology because Unity only likes drawing tiles, and in this case a terrain tile like this with a certain amount of faces or vertices. And the program does its best to try and keep all of the tiny little features in. However, it's going to be based off of certain limitations that we cannot necessarily control for. So in ArcMap, simply load up your LiDAR data. 361 minus 276 is 85. So adjust your height, 1085. And now you have an accurate representation of the height values. If, for whatever reason, you are a little suspicious of this, the easiest way to check is to take your height value data, bring it into Arcscene, and build base heights off of that. However, in this case, this is pretty accurate in terms of the topography. We have the river, the hill, the river flows around here, and our town proper will be in this section right here. Alright, so we have successfully created our terrain. Now let's bring in the structures. Specifically, let's bring in the footprints. You're going to want to grab, drag, and drop in your anchors, which you can see here. Move just your anchors into place, aligning them with the three corners that you had them set up to act as, or act with, in Arcscene. Check all of your corners. Now, it's not going to be 100% exact. There is a little bit of modification that takes place during the process. So you will be off by a few feet to a few inches to a few meters, depending on the data that you use. In this case, we look to be a little bit off there. However, for the most part, we seem to be pretty accurate. Now, if we wanted to, I could just weave this in, and we now have at least a basic idea of where structures are located. However, we do not necessarily want these giant anchor points still in the program. So, while weaving the anchor point in, drag and drop your buildings tutorial file. And you want to move that right over these files. Off just a little bit. Alright, go ahead and you can either just turn off your anchor points or just remove them. Drop your structures down. Now, this is where the resolution of your files and your terrain kind of hurts, in that there is going to be a little bit of a warping effect based off of from the GIS to these files. And why I kind of recommend what you do is what we did not with these structures where we included them with the GIS, but we actually built the models separately. And then import them separately. Now, they're going to be huge. As you can see here, this structure is gigantic. However, you can easily modify it. Typically, the scale is about 20 times what it should be. Or more. In this case, it is more. But we know what the footprints look like for these structures and how big the structure should be theoretically, because we still have the footprints in place. All you will need to do is move the structure until you get it close to where it needs to be. And scale it down a little bit more. Now we've made it too small. So adjust. It's looking pretty close. Might be a little bit too big. So let's split the difference. That's looking better. And it also looks like it needs to be rotated. So let's rotate it. So it matches up. So it looks like if you make the scale approximately 2.5%, 0.025 of the scale that you brought in the file for, you will have the appropriate size. Drag and drop, turn off your file, and now you have your structure in place. Remember when we added the 2 feet of base and foundation? That will allow you to be able to drag and drop and make it higher or lower. In some cases, depending on the terrain that you're working with, you may need to add some more foundational support for your structure. Then, if you need to see the footprints again, you turn them on and do the same thing with the next structures. This process can take some time, but it also allows you to keep everything modular. So let's say we decided to bring in a much nicer model of this structure after we created a nicer model. It'd be a simple matter to simply delete this one and replace it with the other one. Additionally, it's very simple to replace the structures. Now, once you have the structures in place, or even before you have the structures in place, Gaia also allows you to do things with your environment. See here, you can see where the river would be based off of height values. But let's go ahead and very quickly just build a nice little environment. Gaia, Manager, Advanced. Let's go ahead and create spawners. Spawners, and there are tutorials for this made by Adam Goodrich. Let's go ahead and just use some of these basic spawning tools. This spawning tool creates textures, so it gets rid of this white, sandy, dark, dirt-based texture. And based off of procedural model generation rules, it is going through and it will create textures for the ground, and you can modify these rules as necessary. Again, Adam Goodrich has some very good tutorials for this information. If you remember correctly, these structures, what were along Shanty Row, were right along the riverbank. So the one we are currently looking at is this structure here. And it seems to be in the accurate position. So, distance away from a curve. Distance away from a curve. Like I said, this methodology is not nearly as accurate as it could be in terms of placement. However, it is quicker, cheaper, and this process here with the spawners for environmental features makes the process much shorter than it would be otherwise. Otherwise, you would need to go in and with a paintbrush tool paint individual textures for the ground, add in using a paintbrush tool vegetation and roads and ruts and everything that you would normally need in a reconstruction such as this. This process, which is in real time, and you can still see we're about 95% done with texturing this entire area, takes only a few minutes. And there we go. Now we have some greener areas, and like I said, it would take some adjustments for this. This is just what the basic rules are. Let's go ahead and do object spawner. No, not object spawner. Rock piles, small farms, medium small farms, villages. Let's instead do detail, which are your grasses. Click spawn. And what this is going to do is it's going to add on top of these textures environmental features such as grass, or different types of grass, flowers, and the like. Again, you can modify these procedural generation rules using a number of features, including proximity. We can attach a tag to this structure, add tag, or a layer, and within these rules for these spawners, we can say within X radius of this, do not, or do put textures, vegetation, and the like. This one will take a bit longer, so in the meantime, let's go ahead and add a very basic feature, a character, first-person controller, prefabs, first-person controller, And what that did is it will allow us to actually enter our program once all this information has been spawned. Or better yet, Gaia does have on their manager utilities. Where's it? Advanced. Advanced, add character, add wind zone, and under GX, procedural worlds, camera and light, set linear deferred lighting. And what this is doing is it's establishing environmental effects such as sunlight, what time of day it is, camera effects that make it seem either more realistic or helping with distances and the like. Once this is done and we've added some of the vegetation, we will be able to walk around our reconstruction. Sometimes little errors happen if you do not have the required assets already loaded. In this case, I suspect the assets I did not have loaded are things to do with the cameras. So you can see that the lighting changed based off of adding that. It is still adding materials for our ground. We won't cancel that. Necessary. Oh, let's go ahead and clear that. So now with some of these rules, it just randomly spawns you. What you may want to do is adjust where you start out. So in this case, I'm going to move it closer to our structure. Make sure you're not falling through the terrain, or else you'll just endlessly fall. So we are now above the terrain. Still detail spawning. And if you were wondering about the accuracy in terms of the size of this, let us add Gaia Manager. And don't need to create a session. Show stamper. Make sure that your stamper is on your show ruler. There we go. Negative 1,019 meters and 3,016 meters will give us our terrain sizes. Same thing for height. So remember, in Unity, typically it's best to accept 1 meter as being one Unity unit. Delete that. How are we doing on detail? Detail spawner finished. So if we load up our program by hitting the play icon, now that we have a player in zone, we can see that around our structure, it added details. There's actually a wind zone too. Let's go ahead and delete this and the main camera. Also, it has attached a camera to our object, so go ahead and just delete that. Advanced character. Let's see where it put us this time. Way over here. We want to be closer to the structure. Drop us down so that we are closer to the ground. Play. And then using the arrow keys on your keyboard and your mouse to look around, you can now walk around your reconstruction. If we added trees in the distance, that would also be added. Now sometimes with the deferred lighting, it doesn't necessarily kick in until you hit start and stop, and it will actually change the color a little bit. And you can make modifications as you need to the program after this. But now we have an accurate terrain representation, vegetation, and trees. This will end this part of the tutorial, as well as all 5 parts of the tutorial series. Thank you.